Before we start taking notes, get out a blank sheet of paper and we're going to do some problems. So first, what I'd like you to do is factor and solve the following equation. X to the third minus 2x squared minus 3x plus 6 equals 0. Now please pause this video and really spend a few minutes really thinking about how you could factor and solve this equation. Alright, so if you're turning this back on, you've already thought about this problem and hopefully you have an answer. Maybe you saw that out of the first two, you could pull out an x squared, and out of the second two, you could pull out a minus 3. And then when you did that, these two both have an x minus 2, so then you could pull that out. And you get this is fully factored form. And so then to solve, either this one here equals 0, which means x is 2, or this one here equals 0, so x is equal to plus or minus the square root of 3. So this is called factoring by grouping, and it works great when it works, but it only works in very specific cases that when you factor out of each part, these two are the same. Otherwise, it doesn't work. Let me ask you another question. Now, I would like you to factor this equation. Oops, problem 2. X to the third minus 2x squared minus 5x plus 6. So again, please pause this video and really work on this for a few minutes trying to factor this equation. Be creative. So now if you're coming back to the movie, hopefully you tried factoring this and you got creative, because grouping on this one does not work. So then you have to think, how can I factor this equation? And maybe you thought back to our previous one that we just did, whereas after it was factored and we solved it, these are our x-intercepts. So our theory is for this problem is, if I can find an x-intercept, then I can go backwards and put it in factored form. So that is going to be our strategy. If you can find one x-intercept, then I can divide it out and get factored form. So then we need to figure out, how can I find out what an x-intercept is? Well, mostly right now we're just going to do guess and check. And once you guess a number, how can you figure out if it is actually an x-intercept? Think about that for a moment, please. So hopefully you came up with an idea that if you're testing whether something is an x-intercept, you can plug it in for x, and then this should equal 0 if it's an x-intercept. So that's how we test that, and now we're going to write down our thoughts and learn something useful for this in our notes. So now you can get out your notes, and I'm going to have to try to switch out my pages here. There we go. Your notes, page 42. And this is what's going to be useful for us in this is called the rational root theorem. And so it says that the quantity ax minus b is a factor of my polynomial if and only if, and we're going to fill this in, but let's talk about what's happening. So p of x is our polynomial, and ax minus b is a factor. But it's not necessarily the only factor, so it's multiplied by another polynomial, which are the rest of the factors. And so if it's a factor, that means that if I'm solving for x-intercepts, it would look like this. And this would equal 0 only if this part equals 0 or this part equals 0. But for right now, this is the one we're interested in. So that means ax minus b equals 0. So ax equals b, so x equals b over a. And this would be an x-intercept. So that means that if ax minus b is a factor, that only works if x equals b over a is an x-intercept. And what does it mean to be an x-intercept? That means that if my polynomial does that value, then it has to equal what? Hopefully you have 0. So ax minus b is a factor if and only if you evaluate your polynomial at b over a, it equals 0. In other words, it's an x-intercept. So this is going to be useful for us because if we find one x-intercept, we can factor it out and start factoring the equation. So let's start our first example. We have 2x to the cubed minus x squared minus x minus 3, and I want to factor it. Now there's kind of a second part to this theorem that we're going to write down here. All possible rational roots are of the form plus or minus factors of last term divided by factors of the first coefficient. And that's if they're written in descending order by degree. So you have to write your highest degree first, then go down the line. So what that means in this case is that all my possible roots or x-intercepts of this polynomial up here are going to be plus or minus the factors of the last term. So in this case, my last term, in this case, is -3, but you can ignore the negative because we have a plus or minus in front. So what multiplies to 3? 1 and 3. Divided by the factors of my first coefficient, which in this case is 2, and so 1 and 2 are the only factors of 2. And so now you have to write down all your possibilities. You'll see even though I picked prime numbers, there's still a lot of possibilities. I could be plus or minus 1 divided by 1 is 1, plus or minus 1 divided by 2, plus or minus 3 divided by 1 is 3, or plus or minus 3 over 2. Lots of choices. So, but it's still less than the infinite choices we had before when guessing an x-intercept. So it still helps a lot, but there's still a lot of work to do. So now I need to figure out which of these is an x-intercept. More than one of them might work, but we're looking for one of them. So again, the best way to check for an x-intercept is to check them, and I'm going to start with the easy one. So first I'm going to check positive 1. If I plug in positive 1 to my original equation, I'm going to end up with 2 times 1 minus 1 minus 1 minus 3. Nope, does not work. And so next I'm going to try putting in -1, because that's a pretty easy number. Let's see, I get -2 minus 1 plus 1 minus 3. Nope, that doesn't work. And so you just keep trying them. I'm going to skip to 3 over 2 because I happen to know that's the one that works. So if I plug that one in, I get 2 times 9 over 4 minus, oops, I did that wrong, 27 over 8, sorry, cube it, minus 9 over 4 minus 3 over 2 minus 3. So if I continue that out, I have 27 over 4 minus 9 over 4. Then I'm going to switch the last two terms here to over 4, minus 6 over 4 minus 9 over 4. And you'll see that that does work. So this is a root. So now that I've found a root, I know that x equals 3 over 2 is an x-intercept. So that means I can multiply both sides by 2 and subtract 3, and then that tells me that 2x minus 3 is my factor of my polynomial. So now that I have the factor of my polynomial, I can divide it out of my polynomial and be guaranteed I have no remainder because it is a factor. So now we're going to come up here and we're going to divide out our original polynomial, which was 2x to the third minus x squared minus x minus 3, and divide out 2x minus 3, which is our factor. Hopefully we're good at long division now. Let's see how it goes. And so I end up that my polynomial is equal to 2x minus 3 times x squared plus x plus 1. And then I have to see if I can factor it further. So I'm checking this one here. Can I factor it further? We can do our tests. So I do b squared minus 4ac. My discriminant test, I get 1 minus 4 times 1, which is negative 3, which means it is not factorable further. So this is our final factored form right here. That's it.